All right, good morning, everyone. Happy Friday, Junior. The Friday, Junior, before spring break. After today, we won't be back until April 14th for you all, where we'll be back to our face to face or virtual instruction online. But before we jump into our lesson, I would love to know what you're looking forward to the most during spring break. I think some of you have already been answering, but I'll leave it up for just a bit, give you a chance to write in if you just joined us. Ooh, we have drawings too. Let's see. What are we looking to? So I'm going to show some responses that we already have. So someone says, no work to do, and my birthday's during spring break. Happy early birthday. I hope you enjoy it. AA April. My birthday is this month too. I love April. April babies are the best. Okay, what else? Sleeping in on Tuesday and Thursday. Yes, I understand that. Also, possibly fixing my sleep schedule. Yes, you have to work on that. It's really hard, but it's needed. It helps our bodies out a lot to have a good sleep schedule. Someone says sleeping. I think their sleep schedule is just sleeping the entire time in their bed with the nice red covers there. Let's see. Someone else said nothing much, just going to do some work. Can't really go outside, so nothing. But hey, you can do things inside. Maybe you'll start a workout routine or read a book or do a puzzle, something. You can find something fun to do. I hope you don't just do work. But I am glad that we will be having spring break, and I'm excited for that time, but also excited to get back afterwards. All right, guys, let's get started because I want to make sure we have enough practice time. So today, what we're going to do, we're just going to quickly, I just want to make sure everyone knows how to navigate positivephysics.org. If you're having trouble with that website, can you please write in the chat room for me so I can make sure we talk about that? We are also going to just go over rounding accurately. I've seen some of those issues in some of the work I've been grading, and we're going to talk about significant figures quickly and how to convert numbers into different units because all of that is found on positivephysics.org, and I'll try to go to the website today and show you some of those problems. Sorry. And then we're going to talk about the assessment questions or the work questions that you'll be doing in positivephysics.org. All right. So if you haven't seen it yet, I already have a YouTube channel where you can watch videos. And so I've given a video about how to sign up for positivephysics.org, but I believe most of you here have already done so. But if you know people in the class who haven't, please send them to my YouTube channel so they can watch the video and sign up. Thanks. Okay. So we're going to talk quickly about rounding and significant figures because it's a part of some of the assignments in Unit 1 for speed. So significant figures. So they tell you how many numbers to keep, and then what they have here in these pictures is that they're underlined in blue. So when they say round to 3 significant figures here, these 3 numbers would be significant figures for this first set here because you don't have any zeros. And so if you would round this up to 6 because you have a 7 here. But if you look at the bottom example, the significant figures would be the 4 and the 7, and then this where the 3 is found would be the third one because the zeros before don't matter. So a leading zero, a zero to a left of any number, do not count as significant figures. So do not underline those. But all other zeros are significant. If you are just joining us, the Pear Deck code is XXTVB. I just put it in the chat room. All right. So then also, if the first number after the significant underlined numbers is a 5 or greater, the previous number needs to be rounded up. I've seen a lot of people miss that in some of their work. Make sure if you see that the next number after the last significant figure is 5 or greater, you must change the previous number to 1 digit higher. Okay. So let's talk about conversions, which I think is one of the harder things. We did this at the beginning of the year, but I just wanted to make sure we understood how to do that. So in positivephysics.org, they give a link to conversion factors, but I also have those in this presentation. The presentation will be put up in Google Classroom, but this video will also be put on YouTube. So you're going to use the conversion factors to cancel out anything that needs to be changed. So here they wanted them to go from 0.89 meters to centimeters. And in order to do that, they made this table, which specifically is made to be able to cancel out units that you don't want. So you have meters here and you'll have meters here. And that means if one is above the other, they can cancel out. So when you arrange it and make sure you have your desired units, what you're able to do is multiply across the top and then you divide by anything on the bottom. Let me pull this up so you can see this picture. So and instead of writing MPH for this example, you can have it as MI/H, which will stand for miles per hour. And what they did in this example is that they changed 23 meters per second into 51.5 miles per hour. And they did this by writing here 23 meters per second. And then they knew the conversion factors to go from miles to meters. So they put miles at the top, but they put the meters at the bottom so that the meters could cross out here with the meters at the top. And then they do the conversion factors for seconds to hours, and they put the seconds at the top so it could cross out with the seconds here that were at the bottom, and they put hour at the end, so you would end up with miles over hours. So you multiply 23 times 3,600 at the top, and then you divide by 1,609. But I have another example that would hopefully help. So here are the conversion factors that were provided, and I added one extra, but you can find conversion factors online as well. And we'll use these in an example. So here's our example, our first one. We're going to convert 11 meters per second into miles per hour. So I started off with writing 11.0 meters divided by seconds, or just 1 second. So that's 11 meters at the top and seconds at the bottom of the table. Then I knew that the conversion factor for feet to meters is 3.28 feet over 1 meter. So, and I found that from right here in this conversion factor, 1 meter equals 3.28 feet. But I put feet at the top so that the meters could cross out at the bottom. Then next, I looked at the conversion factor for miles to feet. And so you see 1 mile equals 5,280 feet. And I have miles in blue up here because I want to keep miles. I don't want that to cross out with anything. But I put feet here at the bottom because I want feet to cross out with the feet that I have up here at the top so that they'll get rid of. So now I've gotten rid of meters and I've gotten rid of feet. But now I have to get rid of seconds. And to do that, I use this conversion factor that I found here. 1 hour equals 3,600 seconds. So I put 3,600 seconds at the top so that it can cross out with the seconds I had at the bottom over here. And now I have hours at the bottom. So my answer will be in miles per hour. So I got that part right. So what I had to do was multiply 11 times 3.28 times 3,600, and you get that total, and divide that total by 5,280. And that gave me 24.6 miles per hour. So we're going to try that. Hopefully you're able to write in these boxes, but if not, you can write on something else. But I want to see if you can use that process to convert 131 centimeters into meters. And the conversion factor for centimeters into meters is right here on the metric side, where 1 meter equals 100 centimeters. So you should be able to draw on your screen how many meters is 131 centimeters. I see one person working on it. And if you're not sure, we're going to go over this together. But if you can, I would love for you to try. Okay, I'm going to show one response so that you can see the way you would set it up. And so this person set this up well. And what you would do is they have 131 centimeters right here where that I already placed there. And then they saw the conversion factor was 1 meter and 100 centimeters. So they put the centimeters at the bottom so that they would cross out. And then they have the 100 for the centimeters and the 1 for the meter right up here. You multiply 131 times 1, which would give you 131, and then you divide that by 100. And 131 divided by 100 gives you 1.31 centimeters. Great job. Okay. If we need to go over that again, you guys can like write in or send me a message and let me know. We'll do more of those practices. But it works best with paper. But we have some other problems I want to make sure we know how to do. So we're going to go back to looking at calculating speed. And remember with these equations, if you know 2 out of the 3 variables, then you can determine the third variable automatically. Okay, and I see some people say they're still confused. We might have to do more on conversions. But if you see but let's do speed and then we'll try to go back to conversions. But if you know 2 out of 3 variables in calculating speed, you should be able to figure out the third variable because there are some questions that they provide in positivePhysics.org as well, based off of calculating speed using these equations. So what I want you to try to do is solve for the unknown here. Right now, they told us that the average speed, or with the S with the line above it, is 25.0 meters per second. The time is 4.10 seconds. They want you to tell them what the distance is and what unit the distance would be in. I see some answers coming up. Also, if you can, just to help out your classmates, can you circle which equation you use to find out distance? Good. I see people with the answer. Thank you for circling the equation. Oh, I see there's an issue with units though. Okay, let's look at the response. So yes, this person put in 102.5 meters. Remember, that distance is going to be measured in things like meters or feet or centimeters or inches. It is a measurement of how long something is. So you make sure, so meters per second squared is a measurement of acceleration. That won't be a measurement of distance. And so even though you would have the number right, the units would not be right. So make sure you understand that units are telling you what that number is measuring, because this is the right equation to use, like you see here. And that means that if you multiply 25.0 times 4.10, then you multiply meters per second times seconds, which means that the seconds get crossed out. So let's see. I just saw someone write, I wonder if I can do this here. If you multiply seconds times meters, this is horrible, per second, you see how I'm writing here? The seconds get crossed out and your answer is only in meters. That is how you know that your answer for sure should be in meters. Okay, I'm going to get out of annotation. So yes, this is the correct equation. You multiply 25.0 times 4.1 in order to get that 102.5 meters. Okay, let's see. This is another type of question that is in positive physics as you go through it. And what I want you to do is say which car will win the race and try to fill in these boxes. So let's read the question. So two cars are racing. Car A steadily speeds up from rest to 70.0 miles per hour at the finish line. Car B is already moving 25 miles per hour at the start and maintains a constant speed for the duration of the race. Determine the initial, average, and final velocity of each car and select the winner. Which car will win the race? So for each of them, I want you to try to write in all 6 of these boxes. What is the initial velocity? What is the average velocity? And what is the final velocity? And over here, if you can, or you can just write somewhere, tell me who the winner will be. Will it be car A or will it be car B who wins the race? And if you don't know all 6, just write in the ones that you do know. Okay, I see some writing in. This is looking good. Well done. Keep writing. I am going to start sharing some responses. So let's see so far. So good. So someone realized that it said car A started from rest. That means car A's initial velocity is 0. And then they saw that the final velocity for car A was 70 miles per hour. And then they use the equation to find the average speed, which is found in the slides and is also found in positive physics, where if you add 70 plus 0 and divide the sum by 2, it will give you the average, which would be 35. So the average for this car, car A, is 35 miles per hour. But now car B is already moving at 25 miles per hour at the start of the race, and the speed is constant. That's the most important thing that they've said, that this speed is constant. Make sure you recognize that. And so that means all 3 of these numbers will be 25. And who will win the race? The car whose average is 35 miles per hour or the car whose average is 25 miles per hour? Good. I see a lot of people with this. Who wins, guys? Is it car A? Is it car B? Who wins the race? Anyone put who won? Oh, good. Someone just wrote in. Yes, car A. Good. Car A will win the race because the average velocity of car A is 35 miles per hour compared to car B, which average velocity is 25 miles an hour. Good. Let's see. So those were our practices. And I did say I'll go back to conversions. I just wanted to make sure everyone knew what the assignments are. So all the assignments are on positivephysics.org. We're doing unit 1, but by the time we get back, we're going to go back to energy starting the week after spring break, but we're going to finish the speed unit. So I want you to do all of those that are in this red box. So the average speed rule, the embedded math, the vocabulary and concepts, the preparation, I put presentation problems, oh my goodness, the preparation problems, and then complete problems 1 and complete problems 2. So all of these, so the first 3 are already assigned to you, but then these last 3 are due by April 13th. So the first 3 were already due today, but if you don't have them done, just get them done as quick as possible. Oh, you don't have to turn it in to me. This was a good question someone just asked. I can see it. So you see how I can see the completion and accuracy? I can see the completion and accuracy for all of you, and I'll be inputting those grades in Google Classroom. So I can see how much you've done, and I can see how well you did. And I'll be giving you a completion grade and an accuracy grade for each one. But with that being said, enjoy your spring break. I'm going to stop the recording, but then I'm going to go back to helping out with conversions. Let me give you the enjoy your spring break slide though. There you go. Enjoy your spring break, guys. Thanks for sticking it out with me with physics.